Linear inequalities in one variable. Solving an inequality is the process of finding the set of numbers that make the inequality a true statement. These numbers are called the solutions of the inequality, and we say that they satisfy the inequality. The set of all solutions is called the solution set of the inequality. Okay, this is something new. Set builder notation. It's the set of, that's the curly brackets, all x, this is your variable. This line means such that, and then here's your inequality, x is greater than 0. So this says the set of all x such that x is greater than 0, which means any value greater than 0. So inequalities can be graphed on a number line. The graph helps you visualize the values that make the inequality true. So for greater than, less than, or not equal, we have an open circle. There's no line down here, so this remains open. For greater than or equal, or less than or equal, or equals, there is a line down here. It does include the point, so it is a closed circle. That should be a little bit of a review from last year. Extra ink means extra ink, or whenever you took Algebra 2. When you multiply or divide each side of an inequality by a negative number, the direction of the inequality is reversed. This is a super important thing to know, so perhaps you should highlight it. Okay, maybe a couple stars. When you multiply or divide each side of an inequality by a negative number, the direction of the inequality is reversed. So if we're multiplying or dividing by a negative number, you've got to flip the inequality. Okay? That's really important in case the highlighting in stars didn't clue you in. Super important. All right, let's do some examples. So solve and graph the following. We have 4x minus 7 is greater than or equal to 5. We want to get the x by itself. And just like we would if this were an equation, we're going to start here and add 7 to both sides, which gives us 4x, because those 7's cancel. And we get greater than or equal to 5 plus 7, which is 12. Then we want to get the x by itself. This is multiplying, so we want to undo the multiplying by dividing. And on one side we'll have x, and then 12 divided by 4 is 3. So x is greater than or equal to 3. So let's graph. There's our number line. We need to at least label the 0 on the number line. Then we need to find 3. 1, 2, 3, here it is. Is it a closed circle or an open circle? It's a closed circle. All right. Next, we need to find the numbers that are greater than 3. Is 2 greater than 3 or 4 greater than 3? 4 is greater than 3, so our arrow goes in this direction. That's all you have to do. Oh, well, you do have to write it in set builder notation. So, curly brackets, x such that x is greater than or equal to 3. Okay, let's do another one. So first thing I'm going to do is get all the x's onto this side. So we subtract the 8x on both sides. That gives us negative 2x minus 12 is greater than 2. So now I have to get the numbers all on the same side. So let's get rid of that negative 12 by adding 12. And now we get negative 2x is greater than 14. Okay, now we want to get the x by itself, so we're going to divide by negative 2 on both sides. Oh, we are dividing by a negative number. Since we are dividing by a negative number, what do we have to do? Flip! We have got to flip our sign. So negative 2x divided by negative 2 is x. 14 divided by negative 2 is negative 7. And we're going to flip that sign from greater than to less than. That's all you have to do that's different than solving an equation. Is remember that if we divide or multiply by a negative, we have to flip that sign. So let's graph it. We'll put 0 right here because we know -7 is pretty big negative. So 1, 2, 3, 4, 5, 6, 7. Is it a closed circle or an open circle? It's an open circle. Doesn't have any X rank here, so no X rank here. So we are looking for numbers less than -7. So is -6 less than -7, or is -8 less than -7? -8 is less than -7, so our line is going to go that way. And we write it in set builder notation, x such that x is less than -7. So let's solve an and compound inequality. Compound inequalities involve the word and are called conjunctions. The intersection is the graph of a compound inequality. The graph is going to be where the two lines overlap. So let's solve and graph. So we have -3 is less than 2x plus 1 is less than or equal to 3. So, just like we would before, where we would cover this up and say, this is one equation or inequality, and this is one inequality, we're just going to solve all of it at the same time. So I want x by itself. So I need to go next to x to the plus 1 and subtract 1. And that'll cancel that out. So I want to do that for both the other two numbers. So -3 minus 1 is -4. 3 minus 1 is 2. So we get -4 is less than 2x, less than or equal to 2. Then, I'm still trying to get this x by itself, so I'm going to divide by 2. And I'm going to do that on the other sides as well. So I get -2 is less than x is less than or equal to 1. Now let's graph that. So where's 0? There it is. Then I'm going to find 1. And I'm going to find -2. And are they closed circles or open circles? Well, -2 is an open circle. And 1 is a closed circle because 1 has that extra ink, so we're putting some extra ink in here. And then, see how x is between -2 and 1? Right here is where our lines are going to overlap. Okay? So this is super important. Recognizing inequalities with no solution or all real numbers as solutions. If you attempt to solve an inequality with no solution, or one that is true for every real number, you will eliminate the variable. An inequality with no solution results in a false statement such as 0 is greater than 1. The solution set is the empty set. An inequality that is true for every real number results in a true statement such as 0 is less than 1. The solution set is x such that x is a real number. Okay? Let's do some examples. So let's solve the following. 3 times the sum of x plus 1 is greater than 3x plus 5. Well, let's do some distributing. And we get 3x plus 3 is greater than 3x plus 5. Now we need the numbers on one side, the variables on the other side. So let's get rid of the -3x. Oh, that gets rid of it on both sides. So we end up with 3 is greater than 5. Is 3 greater than 5? No, there's no solutions. Okay, now let's try the other one. Here I have 2 times the sum of x plus 5 is less than 2x plus 14. Once again, I'm going to start by distributing. And that gives me 2x plus 10 is less than 2x plus 14. Let's subtract off our 2x. Oh, they both go away. And I end up with 10 is less than 14. Is 10 less than 14?
Yay!
Yes, 10 is less than 14. This means what we would previously say as infinitely many solutions is x such that x is a real number. Okay? So here is an application of an inequality that I used to do all the time. It's your final course grade. I think I still do it. To earn an A in a course, you must have a final average of at least 90%. On the first 4 examinations, you have grades of 86%, 88%, 92%, and 84%. If the final examination counts as 2 grades, what must you get on the final to earn a 90% in the course? Steps 1 and 2 represent unknown quantities in terms of x. So x is your grade on the final exam. Step 3, write an inequality in x that models the conditions. The average of the 6 grades is found by adding the grades and dividing by a sum of 6. So first 4 exams and the final one counts as 2. That's how we get the 6. To get an A, your average must be at least 90. This means greater than or equal to 90. So there's your inequality right there. We're going to continue this on the next page. So that's the same inequality. We're going to solve the inequality and check. We're going to combine some like terms because we have some numbers and we have a couple x's. So we have 350, which is the sum of these 4 numbers, plus 2 x's divided by 6 is greater than or equal to 90 because we're taking the average of all those test scores. So there are 6 scores, we're dividing by 6. Now we have to get the x by itself. So we're going to times both sides by 6, the whole side. Then, the bell threw me off a little bit. So these will cancel, and we'll get 350 plus 2x is greater than or equal to 540. Then we're going to subtract 350. We're going to get 2x is greater than or equal to 190. Then we're going to divide by 2, and we get x is greater than or equal to 95. If you take all these numbers and add them up and divide by 6, you'll come up with 90. The answer then is you must get at least a 95 on the final exam to earn an A in the course. Okay, one more. Solve and graph the following. We have 2 times the sum of x minus 3 plus 5x is less than or equal to 8 times the difference of x minus 1. First thing we're going to do is we're going to do a little bit of distributing. And that gives us 2x minus 6 plus 5x is less than or equal to 8x minus 8. Now we're going to combine some like terms. We end up with 7x. These are on the same side of the inequality, minus 6 is less than or equal to 8x minus 8. Now we need to get all of our variables on one side, so I'm going to subtract 7x from both sides. You get negative 6 is less than or equal to 8 minus 7 is 1, so just x minus 8. Next we have to get rid of this negative 8, so we add 8 to both sides. And we end up with 2 is less than or equal to x. How do we graph this? Well, we find 2 again. We find 2, that's less than or equal to x. So there's 0, here's 2. It's a closed circle. And the numbers that are x is bigger than 2, so the numbers bigger than 2 are on this side.